Okay, this is example one. We're going to use trigonometric identities. The first thing we're going to do is find the exact value of uh, cosine of theta if sine of theta is 1/4. And this is key here, theta is between 90 degrees and 180 degrees. Now, two things. Our old way of doing this would be by noticing, oh, sine theta is 1/4. So that means I need a y coordinate of 1/4, which happens in two spots on the unit circle. And then once I have that, then I have to make myself a right triangle, Pythagorean theorem, then resolve the right triangle with the new sides to find cosine of theta, and then double check to see that I'm in the right range between 90 and 180. Of course, is in the second quadrant, so I'd want this answer on the left. That's everything that we would do in the old way. And that's still a completely valid way of answering this kind of question. But if we want to use trigonometric identities, what we're looking for is a trigonometric identity that uses cosine and sine at the same time. And lots of times, you're going to default to the Pythagorean identity. One important thing here, if you notice, I'll write a little bit larger for it's easier for you to see. When I am using cosine squared of theta, what that means is I find whatever number cosine of theta is, and then I square it. So I evaluate the cosine, and then I square it. So that's those two things. That's what that means. Um, but I know sine of theta is 1/4. So you know what? All I have to do is plug that in for sine of theta, and then I square it. And now you'll notice you've got cosine squared theta plus 1 over 16 equals 1. Subtract 1/16 from both sides. Cosine squared theta equals negative sorry, no, not negative 15. How about just 15 over 16? Eh, I just subtracted 1/16 from both sides, right? So that'd be 16/16 minus 1/16 is 15/16. That's all that was right there. And now I just have something squared equals square root of, or equals 15 over 16. So I take the square root of both sides. And I get cosine of theta equals the positive or negative square root of 15 over 16. Almost done. At this point, it's pretty handy to think, I want cosine, and I want it to be in the second quadrant, so I have to think about the values of cosine. In the second quadrant, cosine is negative. All those x coordinates are negative in the unit circle. So I don't care about the positive root, I want the negative root. So I bring this on up. Cosine of theta is the negative square root of 15. And what's the square root of 16? Well, that would be 4. And there is your value for the cosine of theta. Pretty nice to not have to write a whole new triangle and then Pythagorean theorem and then like this. It's using these identities is handy. You do have to pay close attention to where they want the solution range to be. Um, that does matter. Okay, because if it had been between 0 and 90, that would have been first quadrant, and cosine is positive in the first quadrant. So I would have gone with the positive root. Let's try this for B here. Find the exact value of cosecant of theta if cotangent of theta is negative 3 over 5, and we want it, see, 270 to 360, that's fourth quadrant. So this is, we want the answer from the fourth quadrant. And it's going to be a positive divided by a negative. So our answer here, we're going to end up wanting the negative on it. Okay. Because cosine is always positive here, but sine is always negative. And cotangent, well, I guess, no, it's about cosecant, which is about sine. So sine is negative. Okay, yeah, so it is going to be a negative answer. Okay. So I have to see if there's some sort of relationship out there between cosecant and cotangent. And this is where you have to look at your chart. You know, I can look through and see cosecant is related to, well, let me just pull it over here. Like I said, you have to have the chart up so that you can see it. So I had to take a picture of it so I could take a look at it here. I'll use the highlighter here. So I notice I've got cosecant and sine, but that's not really going to be what I want. I just use cosine squared and sine squared, and I look through and go, oh, wait a second. Cotangent and cosecant are in that Pythagorean identity. Cotangent squared theta plus 1 equals cosecant squared. So that is the identity I'm going to use. I'm going to use cotangent squared theta plus 1 equals cosecant squared theta. Okay. I already know what cotangent is. Cotangent is negative 3/5 squared plus 1 equals cosecant theta. Square that, we get 9/25 plus, I'll change that 1 over to 25 over 25 right now, equals cosecant squared. And I've got 34 over 25. And that is cosecant squared. Of course, I'm going to take the square root of both sides. And we already talked about cosecant being related to sine, and it's negative in the fourth quadrant. So I'm going to take the negative version of this square root, and I end up with cosecant of theta equals negative root 34 over 25. Now I know I can take the square root of 25, but the square root of 34, see 34 is 2 times 17, which are both primes, so negative 34 over 25 is cosecant theta. So you can see what my process was here. Identify the quadrant. Identify the quadrant. That tells you the sign of the result. Find the trig identity that I want to use and solve. That's kind of like my step 1 part A, step 2 part A. So that's kind of like my 2 steps that I'm going through here.